Good evening, kids. We will see problems which we have discussed in tutorial number 2 in this video lecture. We will see the problems one by one, and the topics which have been covered in the tutorial 2 are computation of electrostatic fields and the forces between the charges. We have discussed different types of charges, point charges, and also continuous charge distributions. So we will see the problems on these two which have been discussed in the tutorial class. First of all, let's get back to the first problem, which you can see the problem here. It states that point charges of 1 microcoulomb and 2 microcoulomb are located at 3, 2, -1 and -1, -1, 4. And you are supposed to calculate a charge which is located at, and also the electric field intensity at that particular point, at this point. So we do have now 2 points where there are 2 charges, Q1 and Q2, and there is another point which is to be considered. So we need the force and also the electric field at this point due to these charges, Q1 and Q2. So let's try to solve this particular problem now. Now, if you carefully see, I'll be drawing the figure. It indicates that there are 2 points. I'll name them as A and B. So there are 2 points. A, which is at B, and the charges at these points are Q1 and Q2, which is equal to 1 millicoulomb. The other one is -2 millicoulomb. And there is another charge at this particular point where we need to determine, let us suppose this is P, which is at 0, 3, 1, and it is having a charge of 10 nanocoulomb. So we need to determine the force at this point P. So this charge will be having a force, and this charge will also exhibit a force. Now this is FAP, and this is F force due to charge at B on charge at P. So now the net force is equal to FAP plus FPT. Both are vectors. So first let us determine the force due to charge at A on the charge at B. We know that the basic formula for force between the two charges is Q1 Q2 by 4 pi epsilon naught epsilon r square into ur, right? This is the force equation. Now I need the force between these two charges A and P. So what I am supposed to write? So I am supposed to employ the charges, the 2 charges, which is this one and this one, and I need, see, this is a constant, this is a constant. I need the distance between these 2 points, and also I do need a unit vector along these 2 points. So first of all, let me determine the distance between A and P. A point is at 3, 2, -1. P point is at 0, 3, 1. So the distance between these 2 points is 3 minus 0 whole square plus 2 minus 3 whole square plus -1 whole square. Right? So see, 3 minus 0, 2 minus 3, and -1 -1. So it is square root of 9 plus 1 plus 4. It is square root of 14. So it is square root of 14. This is RAP, and unit vector along AP is, so when I am asking for unit vector along AP, I will take from P to A, so which we have already discussed in the last video lecture. I will take from 0 to -3 into I bar plus 3 minus 2 into J bar plus 1 minus of minus 1 into k bar by square root of 3 square. See, whatever the difference between these two, it is 3, right? Minus 3 whole square plus 1 whole square plus this is 2 whole square. So what is our answer now? If you carefully see, it is minus 3i plus 1j plus 2k by root 14. Now I have obtained all these values. Now I will determine the force at this particular point. So now force A2. So what are the equations which I do want here? Q1, which is my Q1 is 1 millicoulomb here. Q2 is 10 nanocoulomb. So I'll take it as 1 into 10 to the power of minus 3 into Q2 is 10 into 10 to the power of minus 9. And if you see, see the value here now is Q1, this is Q2, and here what do we have? 4 pi epsilon naught. This is epsilon r, defaultly it is 1 because I haven't mentioned any medium. And 4 pi epsilon naught, 1 by 4 pi epsilon naught, I can directly take it as 9 into 10 to the power of 9, or I can write it as 4 into 3.14 into 8.85 into 10 to the power of minus 12 into 1 into this is root 14 whole square into unit vector. So what is the unit vector here? Minus 3i plus j plus 2k by root 15. Sorry, root 14. So this is FAP. Now if we solve this one particularly, what we will get? See, I think this term and this term, they will accumulate, they will become 10 to the power of minus 12, so which will get cancelled here. Okay, so what we will get here, this is 10 into this vector by 4 into 3.14 into 8.85 into square root of 14 square into square root of 14. So this is the value which we will be getting when we solve this. So let us try to solve this particular problem in detail. So I will write this value here. So what is FAP? Is equal to this is 1 into 10 by 4 into 3.14 into 8.85 into square root of 14 whole square into square root of 14. So I'll try to do the calculation. So the final answer here is it is minus 5.51 I bar plus 1.717 J bar plus 3.43 bar into 10 to the power of minus 3 newtons. So this is FAP. Now similarly, we are supposed to compute BP. Now we will move on to the computation of second force, which is due to point B. Now we have seen that point B is located at minus 1 comma minus 1 comma 4. P is at 0 comma 3 comma 1. Now let's see how this one comes into picture. So FBP, so the charge at B is minus 2 millicoulomb, so I am writing it as this one. Charge at this point, it is 10 nanocoulomb by 4 into pi, this is 3.14, into epsilon, it is 8.85 into 10 to the power of minus into epsilon r, it is 1, into the distance. The distance between these two, if you carefully see, RBP is equal to square root of minus 1 minus 0 whole square plus minus 1 minus 3 whole square plus 4 minus 1 whole square. So it is square root of 1 plus 16 plus 9. So it is square root of 26. And the unit vector along BP, it is from here to here we will take. So it is 0 minus of minus 1 into I bar plus 3 minus of minus 1 into J bar plus 1 minus 4 into K bar. By whatever the magnitude again you will be getting, I think you will be getting again the same 26. You can do square root of 1 square plus 4 square plus 3 square, again you will be getting the same value. So it is I bar plus 4J bar minus 3K bar by root 26. So I'll substitute the same here into this equation. Here what I'm supposed to write, I'm supposed to write root, I'm supposed to write root 26 whole square here into the unit vector, whatever the unit vector which I have obtained here. This is to be replaced here. So if I try to solve this one again, so this will get eliminated. So what I'll be getting here? I'll be getting this simplification. So the answer is going to be, so it will result in this something like this, minus 3 into I bar plus 4J bar minus 3K bar into 10 to the power of minus 3 Newton. So it will result you in 1 minus 1.357 I minus 5.428 J bar minus 4.071 K bar. So this is 10 to the power of minus 3 Newton. So this is the force due to charge at B on point number C. Okay. So now if I want the entire charge, F is equal to F AP plus F BP. So what I must do, I must add both these things. If we see in the last slide, see this was the expression, right? So I will write this one here. So it is minus 5.51. So it was minus 5.51 I plus 1.717 J plus 3.434 K plus what is this one? Minus 1.357i minus 5.428j minus 4.07k into 10 to the power of minus 3. So for both of these things it is common. So this is your final answer. Okay, so whatever the things you are supposed to add I vectors, j vectors and k vectors correspondingly. Okay, so we will add these things. So if you add these things, yeah, 1 minute, let me, yeah, it is plus, sorry, it is minus into minus, here it must be plus, and I think it is also here plus, right? So if we add these things, if you see I vector and I vector, they must be joined, so you will get somewhere around minus 6.867, I think, minus 6 I bar minus, see this is plus 1.717, this is minus 5.428. If you add, what you will be getting, you will be getting somewhere around 3.711, so 711 j bar. It is something around, see this is plus, this is also plus, so you will get something around 7.508 k bar into 10 to the power of minus 3 newtons. So I'll write it as millinewtons. Okay, so this is the total force which is there at point number at point P due to the charges at A and B. Okay, so now this one, if you carefully see, now if he wants to determine the electric field intensity at the same points. So we know that electric field in particular point, if I want to determine, I can directly use the formula. So what is the net force at that particular point by the net charge at that particular point. So the net force I have already obtained in the previous slide. It was somewhere around minus 6.867, right? So I will copy this entire thing here. So it is, yeah, minus 6.8 I bar. I'll write only the first, right? Minus 3.7 plus 7.5. Okay. Yeah, it is minus 3.7j plus 7.5k into 10 to the power of minus 3 newtons, right? So into 10 to the power of minus 3 is there. By what is the charge at this particular P point? It is 910 nanocoulombs, right? So it will be 10 into 10 to the power of minus 9. So what you will get? You will get this thing into 10 to the power of this entire thing. It will lead to your 10 to the power of 5. So you are supposed to multiply this one, right? So what I will do, I will take the second thing also, 610. So I'll take it as 681 I bar plus 375 j bar plus 751 k bar into, still I have added 2, I will added 10 square here, I have multiplied with 10 square, still I am remaining with 10 cube, right? So I will write it as kV per meter. So this is my electric field at P. So this is the way of how we are going to solve this type of problems. And these equations, the equations which we have employed here, the equations are very simple. It is E is equal to Q by 4 pi epsilon naught epsilon R into R square into UR, and the other equation is force, yeah, right? These are the two equations, and these equations are applicable when point charges are there. But when you do have continuous charge distributions, these equations are to be modified. That we will see in our next video lecture. Thank you.